two centers we're going to talk about are the centroid and the orthocenter. Let's start with the centroid. The centroid is the concurrence of medians. Okay, well, what's a median? A median is a segment that you draw from the vertex of the triangle here to the midpoint of the opposite side. Okay, so if the midpoint of this side over here was right there, which you'd want to construct, but let's say just say it is, then I would draw a median from here to there. And the place where they cross, we call that the centroid. Okay, so here's a picture of a centroid. Okay, the centroid is located 2/3 of the distance from the vertex and 1/3 of the distance to the midpoint of the opposite side. So what I'm saying is, in this, if this is my centroid, okay, this is 2/3 of the length of the median. This is 1/3 of the length of the median. So from a vertex to the centroid is 2/3, and from the centroid to the side is 1/3. So here, from the vertex to the centroid, 2/3. From the centroid to the side, 1/3. All right? All right, so if I'm looking at this graph or this picture here, if AD, okay, this whole line here is 120, then AG, from the vertex to the centroid, and I can tell it's a centroid because all these lines are drawn from the vertex to the midpoint of the opposite side, okay, is 120. I would divide 120 up into 2/3 and 1/3. So 1/3 of it would be 40, and 2/3 of it would be 80. So AG would be 80, GD would be 40. Okay? If GB is 14, then GE would be, this is 1/3, this right here is 1/3, so this would be 2/3, so that'd be 28. Okay? FG, if this, again, this from the centroid to the vertex is 2/3, so that's 24, 1/3 would be 12. So we got 28, we got 12. BC, now we're going to get into the whole, this is a median, so it's hitting the midpoint. So finding BC is equal to BA. So if BA is 21, so is BC. And if ED is 19, then DC is also 19. So that makes EC 38, because these two add together. And if AF, find AF if AE is 27. So AE, the whole thing, is 27. AF would be half of that, so that'd be 13 and a half. And this one, same thing, 13 and a half. Okay? Now, the centroid is useful because it is the exact balance center. Like, if you've ever gone downtown and seen a couple of those sculptures out in the sculpture garden at the Ohio or the Columbus Art Museum, there are like sculptures where there's a triangle like balanced on, I don't know, like this little rock thing. Well, the centroid is the exact center of balance. So even if the triangle is thousands of meters in area, you could still find the centroid. And if you put a dot right at that centroid, if you put a balance, it would balance on your finger right at that point. Okay, of course, if it was thousands of square feet, it would crush you, but that would be the exact center of balance. That's the centroid's claim to fame. All right. Now, an orthocenter is the concurrence of altitudes. Altitudes are what you used when you calculated area. It's from the vertex perpendicular to the side. So it doesn't bisect, it doesn't do any of those things. It's just from the vertex straight down to the side. And if you remember, like when you were calculating, or when you were in elementary school and you were trying to find the area of a triangle like this, you had to go from the top perpendicular, and you couldn't draw one perpendicular over here because it would all have been slanted. So you extended the side out, and that was the height of the triangle. Same thing here. If we're finding the orthocenter of an obtuse triangle, that first middle altitude goes through the triangle. So it's from the center, from the altitude perpendicular to the side. But on the other two sides, I can't drop an altitude straight. If I try to go from the vertex down to the other side, they're all going to be slanted and not perpendicular. So to go perpendicular, I've got to go straight down like this. Okay, so from here down, same thing here. I can't go straight over here because that's won't be perpendicular. So I have to go from here perpendicular. And so by extending those lines, obviously those aren't going to ever intersect going out this way. So I have to bring them in to the center in here, and that is going to be my orthocenter. So just like a circumcenter, the orthocenter of an obtuse triangle is outside the triangle. If the orthocenter of an acute triangle is in the middle or inside the triangle, and the orthocenter of a right triangle is on the triangle. Now you'll remember in a circumcenter, the circumcenter was on the hypotenuse. It was here. But if you think about it, from here perpendicular down and from here perpendicular to the side, it's obviously going to meet there. All right, so the orthocenter works kind of like the circumcenter. Okay, if I just were going to sketch the orthocenter, I would draw a perpendicular line straight down this way, a perpendicular line there, and perpendicular line there. And that point there would be my orthocenter. Okay? All right, now orthocenters are something that we do a lot with coordinate proof because it's pretty easy to calculate the altitudes. Think about it's got to be perpendicular because it needs to make a right angle, and it comes straight from the altitude or from the vertex. So if I'm going to start here and I want to be perpendicular to a horizontal line, that's vertical. So there's my one altitude. Okay, now the other two get a little trickier because obviously they're slanted. So I got to find the slope using this point and this point. I got to use the slope. So I do y2 minus y1 over x2 minus x1. So that gives me negative 4 over 4 or negative 1. So the slope of this line right here is negative 1. Okay? I don't want to use blue there. So if I'm going from here, from this point here, perpendicular to this side. So I'm going to start here and go down 1 over 1 or up 1, up 1, left 1. Did I calculate that right? Yeah. So right and down, that would be that way. So if this is the slope of this line here, okay, I want the perpendicular, so I need this to be the opposite reciprocal. So that means the perpendicular slope is going to be 1. So I go up and over. So start here, go up 1 over 1, up 1 over 1, up 1 over 1, and so my altitude would be there. Okay, now if I want to do this line over here, again, I'm going to find the slope, y2 minus y1 over x2 minus x1, so that's negative 4 over negative 2, or 2. So the perpendicular slope would be negative 1/2, because it's the opposite reciprocal. Turn this upside down, change the sign. So again, I'm calculating it from this side, so I'm going to start from this side, okay, because I'm trying to get over 2 here. So I go down, let's see, go up 1, left 2, up 1, left 2, up 1, left 2. So my last perpendicular line would be there. Okay, don't those all look here like they're making right angles? We got a right angle there, we got a right angle there, we got a right angle there. And this point right there, which is negative 2, 4, is my orthocenter. Okay? Okay. So that I don't have to take all of this time, like take up too much of your time now or in class tomorrow, I'm going to have you do 1, 2, and 3 now, and then tomorrow in class we're going to do 4 and 5. So just pause the tape, do number 1, number 2, and number 3, and then tomorrow in class we'll do 4 and 5. And that way we kind of take a little bit of time now and a little bit of time in class.